You know that look? We've all seen it. A river or a lake that's just cloudy, kind of murky. And you might just shrug and think, it's just mud. But the real story, well, it's happening at a level you can't even see. So what is really hiding in that cloudy water? Let's dive in and find out.
Yeah, it seems like a pretty simple question, right? And sure, dirt is definitely part of the answer, but it's nowhere near the whole story. The scientific term for what's really going on is a super important indicator of how healthy, or how unhealthy our water really is.
And that term is total suspended solids, or TSS for short. Now, the most important word there is suspended. This isn't like sugar dissolving in your tea. This is more like dust floating in a sunbeam. We're talking about actual physical particles that are just hanging out in the water, too light to sink.
Okay, so what exactly are these microscopic culprits making our water all cloudy? Well, it's not just one thing, it's actually a whole cocktail of tiny little particles. So let's zoom in and get a closer look at what's in the mix.
This cocktail is made of materials that scientists basically split into two big groups: the stuff that was never alive and the stuff that was, inorganic and organic.
So on the inorganic side, the non-living stuff, you've got things you'd probably guess. Tiny bits of sand, silt, and clay, even little rust particles. But the organic side? That's where it gets really interesting. We're talking about algae, bacteria, bits of decaying plants, and yep, even biological waste. It's this complex mix that really defines the TSS in any river or lake.
So, if TSS is just this big mix of microscopic floating bits, how in the world do you measure it? It's actually a really precise science, and it all goes down in the lab.
I mean, it sounds like a pretty tough challenge, right? You can't exactly go in there and count every single particle. So how do they do it? Well, scientists came up with a really clever and super reliable method to get an exact measurement.
And here's the secret. You don't count them, you weigh them. The method is called gravimetric, which is just a fancy way of saying it's all based on weight. The whole goal is to separate those solids from the water and just see how heavy they are. So here's how it works, step by step. First off, you take a special glass fiber filter and weigh it very, very carefully. Then you pour a specific amount of your water sample right through it. The water goes through, but all those little solids, they get trapped. Next, you pop that filter into a scientific oven to bake off every single drop of water. And finally, you weigh the dried filter one more time. The difference in weight between the start and the finish? Bam! That's your total suspended solids. So simple, but incredibly effective.
And that final number, that weight, gets reported in milligrams per liter. Using a standard unit like this means scientists and regulators all over the world can be on the same page, they can compare notes and know exactly what they're talking about when it comes to water quality.
Okay, so we can measure it, we get a number, but so what? Why does this number matter so much? Well, when that number gets too high, the consequences for our environment are, frankly, pretty severe.
It might sound a little dramatic, but it's true. High TSS is basically a silent killer for aquatic ecosystems. When these levels spike, the damage to our rivers, lakes, and streams can be absolutely devastating, creating a ripple effect through the entire food web. Let me break down how this damage happens. First, all that floating stuff makes the water cloudy, which blocks sunlight from getting to the aquatic plants below. No sun, no photosynthesis, no oxygen. Then, as these solids eventually settle, they can literally smother fish eggs on the riverbed, destroying breeding grounds. Plus, as all the organic junk decomposes, it sucks up the oxygen in the water that fish need to breathe. And if that wasn't enough, these little particles act like tiny taxis for other pollutants, like heavy metals and bacteria, giving them a free ride through the ecosystem.
It all sounds pretty grim, I know, but here's the good news. We have the technology and the infrastructure designed specifically to fight this problem. So let's flip the script and look at the solution.
And on the front lines of this fight are wastewater treatment plants. They really are the unsung heroes here. One of their most important jobs is to remove as many of these suspended solids as possible before that water gets returned to the environment.
And to make sure they're doing their job right, they are held to a very, very specific standard. There is a magic number they absolutely have to hit to be in compliance and to protect our ecosystems.
And this is it, less than 30 milligrams per liter. That is the common legal limit for TSS in treated water that's being discharged back into a river or a lake. It's a strict, non-negotiable target.
Now that number isn't just pulled out of thin air.
It's written right into environmental laws and regulations. It's a key part of the discharge permits that plants need to operate. This is the legal line in the sand that separates clean water from pollution.
So when you really think about it, TSS is so much more than just a measurement from a lab. It's a vital sign for our planet's water. You know, just like taking someone's blood pressure tells you about their health, measuring TSS tells us exactly how healthy our most precious resource really is.
And all of this leads to an even bigger question. We're getting really good at filtering these solid particles from our water, but as we just saw, those particles can carry other, invisible pollutants with them. So the next great challenge is figuring out how we tackle the threats that we can't see.